Now we are going to discuss Livoli extension of Dirichlet's theorem. It says, so if x, y, z are all positive such that h1 is less than or equal to x plus y plus z less than s2, then triple integral f(x plus y plus z x l minus 1 y m minus 1 and z n minus 1 dx dy dz is equal to gamma l gamma m gamma n gamma l plus m plus n integral fu u l plus m minus m l plus m plus n minus 1 du h1 to h2. So this is very important. This has huge application. Like I'll take an example to explain this how it works. So let's suppose we have to evaluate. This is the question. Evaluate triple integral e to the power x plus y plus z dx dy dz taken over the positive octant of the octant such that x plus y plus z is less than or equal to 1. See, this satisfy. This is satisfy this Dirichlet condition. In fact, Livoli extension. This is basically 0 x plus y plus z equal to 1. So in first octant x, y, z, they all will be non-negative. So we can write this. So here h1 over here is 0, h2 over here is 1, and what is your fu over here? See, fx plus y plus z is ex plus y plus z. So fu, you take this as u, right? So this is eu. So this integral will convert to using Livoli extension. So will give you, so you have x 1 minus 1, y to the power 1 minus 1, z to the power 1 minus 1. So this is l is 1, m is 1, n is 1, and this is 3, 0 to 1, and this is u to the power 1 plus 1 plus 1 minus 1. So this is square du. So this is 1 to the power 2, 1 by 2, gamma 3 is 2 factorial, and we have to integrate this. So how will integrate this? We can use integration by parts, right? We will use integration by parts. That will give you 2u eu plus 2eu 0 to 1. Alright, so this will give you 1 upon 2. This is e minus 2e plus 2e minus 2. So this is basically 1 by 2 e minus 2. This is your answer. So we can solve this integral. We have solved this integral very easily using Livoli extension. I'll take one more question. So this is a problem. Find the value of triple integration log x plus y plus z dx dy dz. The integral extending over the positive value of x plus y plus z subject to the condition x plus y plus z is less than 1. So let's solve this. So this is, here your, I can say 0 x plus y plus z is 1. So here h1 is 0, h2 is 1. So this integral can be written as x1 1 minus 1, y 1 minus 1, z 1 minus 1, and log x plus y plus z dx dy dz. This will be equal to gamma 1, gamma 1, gamma 1, gamma 3, 0 to 1. This is u to the power 1 plus 1 plus 1 minus 1 u square log u du. So this will be 1 upon 2, and integral can be solved. Integral can be written as, we can write this as u cube by 3. This is u cube by 3 log u. We are using integration by parts. You might be aware of it. So this is differentiation of log u and integration of u squared u cube by 3 du. So this will be, here the limit will be 0 to 1, here also the limit will be 0 to 1, right? So see this, if I put 1 it is 0. If I put 0 and take the limit u tending to 0, u cube log u, it will also come out to be 0. So this is 1 by 2 0 minus, we integrate this is 1 by 3 and this is u square, so u square will give you u cube by 3 and the limit will be from 0 to 1. So finally what you get is minus 1 upon 18. So this will be our answer, minus 1 upon 18. Now let us discuss another question. I love this. Let us discuss another question. We have to evaluate this, e to the power minus x square minus y square dx dy, where d is the region bounded by the circle in the positive quadrant. So before doing this, we have to convert it into the form where we can use Livoli extension. So it has to be a function of x plus y. So for that we have to put a transformation. Let x square equals to, say, I take it as u and y square as v. So this will give me x equals to u half and dx will be 1 by 2 u minus half du. This can be written as y equal to v half and dy will be given by 1 by 2 v minus half dv. So the integral will give you, this integral will convert to e to the power minus x square y square dx dy will come as 1 by 4, and I can write e to the power minus half as half minus 1 minus of u plus v du dv. So this will give you 1 upon 4 gamma 1 upon 2 gamma 1 upon 2 gamma 1 and integral, we can write this as 0 to r square. This is u half plus half minus 1, that is a 0 only. So it is 1 e to the power minus of I can write this as, say, u plus v can be taken as t and dt. So this will be pi upon 4 and this integral will be e to the power minus t 0 to r square. So this will give you pi upon 4 1 minus e to the power minus r square. So this will be the integral, this will be the solution. So here you find that we have huge application of Livoli extension and the Dirichlet's theorem in multiple integrals. We will have this application of this in volumes also, in calculating the volume, in calculating the triple integration. This is very, very important. You must remember this.